Okay, let's get right into it. We all see the incredible things AI can do. But today, we're pulling back the curtain. We're talking about the physical world, the concrete, the copper, the cooling systems that this whole revolution is built on. And from an engineer's perspective, that foundation is starting to crack. This is a briefing on the infrastructure crisis that's unfolding as we speak.
And look, this isn't just some technical issue for engineers to solve in a lab. As Peng Zhou puts it, this is a C-suite level headache. The sheer density of AI compute is forcing a complete overhaul of data center economics. We're talking about fundamental questions of cost, risk, and reliability that every CIO is losing sleep over.
So here's how we're going to break this down. First, we'll get a handle on the sheer scale of the power demand. Then, we'll look at exactly why our old ways of cooling are failing. From there, we'll talk about what a new data center has to look like, why liquid cooling is the future, weigh the tough choice between building new versus trying to upgrade, and finally, wrap up with why we desperately need a new industry standard. Let's get started. First things first, we need to understand where all this pressure is coming from. And it all begins with a demand for power that isn't just growing, it's exploding. Now, this isn't some temporary spike, a 27% compound annual growth rate. You know what that means? It means the demand for these AI systems is more than doubling every 3 years. Trying to build physical infrastructure to keep up with that pace is, well, it's a monumental challenge. And here's the kicker. It's not just about more people using AI. The models themselves are becoming unimaginably more complex. We've leaped from models with millions of parameters to models with trillions. Every single one of those wow moments from a new AI requires a gigantic leap in the power needed to run it. This has completely changed how we design data centers. The old method of just stacking individual servers one by one, it's obsolete. The communication between them is just too slow. Modern AI needs these huge, tightly woven clusters. We call them supernodes that are all connected together. And cramming all that compute so close together is what creates these insane hotspots of power and heat. So you've got this incredible concentration of power. And that brings us to our next problem, the unchangeable laws of physics. The amount of heat coming off these clusters is pushing our current cooling technology right past its breaking point. This chart right here really tells the whole story. A standard server rack used to draw maybe 15 kilowatts. Today's AI racks are hitting 50. And the next generation? We're designing for racks that will pull down over 300 kilowatts. Let me be clear. You cannot cool that with air. It's just physically impossible. And let's zoom right in, down to a single chip. Once an individual GPU or CPU starts cranking out more than 600 to 800 watts of heat, plain old air just can't carry that heat away fast enough. We have hit a thermal wall. This isn't about being more efficient anymore, it's about the physical limits of the medium we're using. Because of this, the industry has had to create a whole new classification, the AIDC, or Artificial Intelligence Data Center. And trust me, this is not just a marketing term. It's an entirely new breed of building, engineered from the ground up specifically for these insane workloads. This means we have to rethink everything. An AIDC isn't just about what's inside the rack. It's about rewriting the blueprint for the entire building. The pressure is hitting the facility from every single angle. Cooling is the obvious one, sure, but the power demands? A single AI cluster might need hundreds of megawatts. That's enough to power a small city. The building itself, the concrete floors, might not be strong enough to hold the equipment. And the networking? We need about 10 times more fiber optic cable than ever before. It's a systemic problem. Here's a problem you probably wouldn't even think of. Many of our existing data centers are just not tall enough. I'm serious. The floor-to-ceiling height simply doesn't leave enough room for the massive pipes and heavy-duty power lines we need to run these new AI clusters. So all of this leads us to the one engineering solution that's basically become a requirement. It's not an option anymore.
We are officially entering the era of liquid cooling. And the trend is crystal clear. Projections show that in just a few years, more than 90% of the cooling in these new AIDCs will be liquid-based. The industry isn't just exploring this, it's stampeding toward it, because frankly, there's no other way to go. So, how does this stuff even work? Well, one of the coolest methods, no pun intended, is two-phase immersion cooling. It sounds complicated, but it's actually an incredibly elegant cycle. You literally dunk the servers into a special non-conductive fluid. The heat from the chips makes that fluid boil at a really low temperature, about 50 degrees Celsius. The vapor rises, hits a cool surface, turns back into liquid, and just rains back down on the hardware. It's a perfect, self-contained loop. And this is not a science project. The big players are already doing it. Microsoft is using this exact technology and is seeing major power savings. So not only does it solve the heat problem, it actually makes the whole operation more energy efficient. That's a huge win-win. Okay, so this brings every CIO and facility planner to a massive fork in the road. Knowing all this, do you try to upgrade your existing buildings, or do you just have to bite the bullet and start from scratch? Well, the engineering consensus is pretty much unanimous. Building new is the way to go. It lets you design everything, the power, the cooling, the structure, to work together perfectly without any compromises. Trying to retrofit an old building, well, that's just a world of pain. It's full of risks, hidden costs, and you'll always be held back by the limits of the old design. And I'm not exaggerating. Just look at the list of challenges. You're not just adding a few pipes. You're probably ripping out and replacing the entire power grid. You have to get engineers to confirm if the floor can even hold the weight of all the new gear. You might need a whole new chiller plant. And you're doing all of this while fighting that constant battle of not having enough space. It's a nightmare. Which leads us to the final and maybe the most critical point. This problem is simply too big for any one company to solve on its own. If we want to move forward, the entire industry has to start working together. Because right now, we're heading towards chaos. You have every company designing its own unique, custom solutions. To avoid that future, we have to agree on some common standards for things like the main cooling units, the types of fluids we use, and even for plug-and-play power systems. Without that, we're just building a future of expensive, incompatible parts that will slow everybody down. When it all boils down, this is about making sure the AI future is actually sustainable. All the amazing progress happening in the digital world is completely dependent on our ability to solve these very real, very physical problems in the world of concrete and steel.
So I'll leave you with this one question. AI is not slowing down. It's only getting faster. The real test is whether we, as engineers and builders, can evolve the physical world fast enough to keep up. Can we actually pour the concrete and lay the pipes fast enough to contain this explosion? That's the challenge that defines the next decade.